Hi folks, today we're going to talk about special right triangles and reciprocal trig functions. Two different topics, but both really important because these are the foundations of trig that you're going to use throughout all of the different units that we do with trigonometry. So we'll start with our special right triangles first. We have two of them. We have the 30, 60, 90 and the 45, 45, 90. If this is my right triangle and this is my 30-degree angle, this is my 60-degree angle. If I were to go ahead and populate the sides, I know that the sine of 30 is 1/2. And the only reason I know that is because I've been doing this for a while, but you can check that in the calculator. If you put in sine of 30, you'll get 0.5. Remember that sine is opposite over hypotenuse, so that would give you 1 for the opposite side, 2 for the hypotenuse. Now, we can find the third side of our triangle by doing Pythagorean theorem. 1 squared plus b squared equals 2 squared, right? And that, when we solve for that, we would end up with √3 as the third side. So, when I'm populating this table, I can get all of my values right from my triangle. Sine of 30 is 1/2. Cosine of 30 is radical 3/2. And the tangent of 30, opposite over adjacent, is 1 over radical 3. When you rationalize that, you end up with radical 3/3. By rationalize, all I mean is multiply the top and the bottom by the radical that's in the denominator. It gives you radical 3/3. And let's move over to the ratios for the 60-degree angle. Sine of 60 is radical 3/2. Cosine of 60 would be 1/2. And the tangent of 60 would be radical 3. Notice sine of 30 and cosine of 60 are the same. Cosine of 30 and the sine of 60 are the same. That's going to come up a little bit later on, but just recognize that. These are exact values, so when it asks you for an exact value, that doesn't mean they want a decimal approximation. That doesn't mean I want you to put sine of 60 in your calculator and you give me what the decimal is. It means I want you to write radical 3/2 for the exact value. In the 45, 45, 90 triangle, also called an isosceles right triangle, those sides are the same, those angles are the same, these sides have to be the same. The tangent of 45, opposite over adjacent, would be 1, so I can write that as 1/1. And if I did Pythagorean theorem, I would end up with radical 2 as my hypotenuse. So the sine of 45 is 1 over radical 2. When you rationalize that, you end up with radical 2/2. And that would be the same for the cosine. And your tangent then would just be 1. So you can use this sheet then and have it sort of as a reference. Hopefully you copied all this down on your sheet while we were going through the video here, but you can use this kind of as your reference, okay? Let's talk about reciprocal trig functions. Reciprocal means when you take a fraction and you flip it, right? So if I have 5/8 as my fraction, when I take the reciprocal of it, I end up with 8/5, which is also the same, right? 8/5 is the same as saying 1 over 5/8, right? If I do have 1 divided by 5/8 is the same as 1 times 8/5. Okay, so that's just a quick little review of reciprocals and dividing numbers and the fractions and all that sort of thing. But here's the idea here. If this is my triangle, my right triangle, and this is, I'm just going to use 3, 4, 5 as my triangle, which is true, right? 3 squared plus 4 squared equals 5 squared, so I know that that's legit. Let's talk about the sine ratio. We'll call this angle up here, we'll call that theta. Okay, so the sine of theta would be opposite over hypotenuse, that would be 3/5. The cosine of theta would be 4/5, and the tangent of theta would be 3/4. fourths. So remember, this is opposite over hypotenuse, this is adjacent over hypotenuse, and this is opposite over adjacent. When we start talking about reciprocal trig functions, we can take the reciprocals of all of these, and they each have their own name. And when I take reciprocal, that means I flip this. Okay, so this is what I'm flipping. When I flip it, I end up with hypotenuse over opposite. There's a name for that. When I flip this one, I end up with hypotenuse over adjacent. There's a name for that. When I flip this one, I end up with adjacent over opposite. And there's a name for that. Each of these are written down here, and it's kind of counterintuitive as to what goes with what. So make sure you pay close attention, because this is where people tend to screw up, because what they think should go together doesn't necessarily go together. Let's start with cosecant, which we abbreviate as CSC. So the cosecant of an angle is the reciprocal of the sine. So that would be the reciprocal of sine. So 1 over the sine of theta. Well, the sine, remember, is opposite over hypotenuse, so 1 divided by opposite over hypotenuse is the same as 1 times hypotenuse over opposite, right? So it would be hypotenuse over opposite. Okay, so your cosecant is 1 over your sine, so you flip your sine ratio. Your secant, abbreviated SEC, so secant theta, is the reciprocal of your cosine function. So it would be 1 over the cosine. Well, I know that cosine is adjacent over hypotenuse, and when I take the reciprocal of that, I end up with hypotenuse over adjacent. Cotangent, abbreviated COT for cotangent, would be 1 over the tangent ratio. So that would be 1 over opposite over adjacent, which would then be 1 times adjacent over opposite, which gives me adjacent over opposite. So cosecant is the reciprocal of sine, and you can reverse it, and you could say sine is the reciprocal of cosecant. So I could also write this as sine of theta is equal to 1 over the cosecant of theta. And I can rewrite this and say, well, the cosine of theta is equal to 1 over the secant of theta, and I can say that the tangent of theta is 1 over the cotangent of theta. So make sure that you know this as well. This is something you want to make sure that you memorize. Again, things that don't go together seem like they should go together. Just keep that in mind. Tangent ones are easy. They always go together. But cosecant and sine, you wouldn't think are reciprocals of each other, but they are. So let me show you a couple examples of how you would use this in a problem. So let's say I gave you, we can start with a really basic problem. Let's say I just gave you this triangle, and I said, whoops, here's my triangle, and here's theta, and I gave you 20, 15, 15, and 25. And I said, tell me what the cosecant of theta is. Well, remember, cosecant flips sine. So sine, right, that's 1 over the sine. Now you don't have to write this step here. I'm just writing this so you can see what it is I'm doing. But just remember, cosecant flips sine. So if sine is opposite over hypotenuse, then if I flip that, it's hypotenuse over opposite. So that would give me 25 over 15. And then if I reduce that, it would give me 5 over 3. Okay, so remember, when you're doing these, you're always, with reciprocals, you're always flipping. Let me go back to this. Notice these ratios here my sine and my cosine, we talked about this in the last video, that they can never be equal to 1 or greater than 1 because my hypotenuse is always the longest side of my triangle. And my denominator is always going to be greater than my numerator. When you take the reciprocal trig function, so when you take the reciprocal here or the reciprocal here, now your hypotenuse is in your numerator, which means that for the cosecant and the secant trig functions, it's always going to be greater than 1 because I've now flipped these fractions. Okay, so when you're dealing with cosecant or secant, this answer should always be, it has to always be greater than 1. Tangent, there aren't any restrictions on it, so there wouldn't be any restrictions on cotangent either. Okay, so that's the idea behind solving one of those problems. How about if I gave you something like this? Find the secant of theta if the, let's see, if the sine of theta was equal to 5/13 or something like that. The first thing I would do with a problem like this is I would draw a picture. I'm a very visual person, so pictures are very helpful. I think whenever you can draw a picture is going to be helpful, especially when you're dealing with trig. So here's my triangle, here's my theta. I know that the sine is 5/13, so that would be opposite over hypotenuse would give me 5/13. And it's telling me to find the secant. Now, in your head, you got to say, okay, well, secant flips cosine. So cosine is adjacent over hypotenuse, so this is going to be hypotenuse over adjacent. Well, I have the hypotenuse, but I don't have that adjacent side. I need that. However, I do know two sides of my triangle, so I can find that third side simply by doing Pythagorean theorem. Whenever you're given two sides of a right triangle, you can always find the third. So if I were to do 5 squared plus x squared is equal to 13 squared, you might recognize this as a Pythagorean triple. If not, you have 25 plus x squared is equal to 169. So x squared is 144. So x comes out to be 12. And so the secant of theta then, I'm not asking you to solve for theta in this problem. I'm just asking you what the secant of theta is. So I'm just asking you for the ratio. You're doing hypotenuse over adjacent, so that would be 13/12. And that's your answer for that. Okay. There's one other thing that's on your sheet. On your note sheet, it talks about degrees and minutes. When you are dealing with trig, we actually can represent our angles in just decimal format or in degrees. There's 30 minutes in a degree, or excuse me, there's 60 minutes in a degree, 60 seconds in a minute. Okay, and that works in our angles as well. This you can do in your calculator. So let's say you've got, like on your paper there, you've got maybe 52.5 degrees. Let me clear this out. 52.5 degrees. If you hit the second and then the apps key, you get all of the angle menu problems here. Go down to DMS. That changes the format into degrees, minutes, and seconds. Press enter and press enter and it'll give it to you. 52 degrees, 30 minutes, 0 seconds. So when you're rounding, remember that 30 minutes is the halfway point. So anything above 30 minutes would round the angle up. Anything below 30 minutes would round the angle down. Okay, but that's how you would go about doing that. We'll get some practice with some problems like that, but I just wanted to kind of bring that to your attention. So let's say, for example, you've got 48.75 degrees. Do second apps, and you go down to DMS. It'll convert it for you. Just enter again, 48 degrees, 45 minutes. So you can always go to the calculator And as you change the decimal here, it'll change your, it'll put it into the right format for you. That's it for this video. See you next time. Take care, everybody. Bye-bye.